Hey, what's up? It's Jake from Newest DevOps, and today we're going to be talking about the Cloud Digital Leader certification from Google. We're going to continue on with Section 1, Digital Transformation with Google Cloud, but we're going to go to Section 1.2. This has been pushed up to my GitHub repository, so feel free to take a look and read all of my source documentation if you choose to do so. The goal here is to cover fundamental cloud concepts by explaining them in general. The Cloud Digital Leader Certification Exam Guide lists the 5 specific areas that we need to focus on. The first area has us describe how transitioning to a cloud infrastructure affects flexibility, scalability, reliability, elasticity, agility, and total cost of ownership. We want to apply these concepts to various business cases. Cloud computing gives your business more flexibility. You can quickly scale resources and storage up to meet business demands without having to invest in physical infrastructure. Companies don't need to pay for or build the infrastructure needed to support their highest load levels. Likewise, they can quickly scale down if resources aren't being used. The cloud delivers more flexibility and reliability, increased performance and efficiency, and helps to lower IT costs. It also improves innovation, allowing organizations to achieve faster time to market and incorporate AI and machine learning use cases into their strategies. The source I have here is from the Advantages of Cloud Computing. I highly recommend reading this document in its entirety because a lot of what you need to talk about and cover on the exam is definitely on this entire page. Next, we want to explain how an organization's transition from on-prem to the cloud shifts their capital expenditure to operational expenditure, or CapEx to OpEx, and how that affects total cost of ownership. Businesses of any size can experiment with tools in the cloud and try new things without fear of a huge upfront investment. It also allows startups to get invested right away because they don't have to have a bunch of capital up front or do a bunch of crowdsourcing and fundraising in order to fund these ideas that they have. In general, it's super expensive to maintain a data center. If you have servers and a rack or cage in a data center, you got to pay for security, you have to pay for power, you have to pay for all the stuff that goes along with having a data center. Additionally, you have to replace the hardware when it gets deprecated or when you have failures. With the cloud, you just turn it on, you try something, you turn it off, you throw it away, you build a new one, no big deal. So this shift in how you do business also is a shift in how you spend money. You're going to shift how much money you spend up front in exchange for shifting to a pay-as-you-go model, which is the OpEx part of trading from CapEx to OpEx. This will bring the total cost of ownership down because not only are you reducing the overhead overall, because the cloud, if used properly, is less expensive than using an on-prem data center, but you don't have the upfront capital expense that tapers off as well. Next, we need to identify when private, hybrid, or multi-cloud is probably a better idea and what those use cases are. Public clouds are run by third-party cloud service providers. They offer compute, storage, and networking resources over the internet, enabling companies to access shared on-demand resources based on their unique requirements and business goals. Private clouds are built, managed, and owned by a single organization and privately hosted in their own data centers, commonly known as on-premises or on-prem. They provide greater control, security, and management of data while still enabling internal users to benefit from a shared pool of compute, storage, and network resources. Hybrid, on the other hand, combines public and private cloud models, allowing companies to leverage public cloud services and maintain the security and compliance capabilities commonly found in private cloud architectures. You'll hear right now that there's a fad of people going back into the data center because the clouds become too expensive. It completely depends. But hybrid environments are extremely popular, especially among companies that have certain specific compliance requirements. Next, we're going to define some basic network infrastructure terminology, and I'll just go through the list. First, you have IP addresses. This is just a unique identifying number assigned to every device on the internet. Next, we have an ISP. And they basically provide you with access, or an organization with access to the internet and other related resources. Then we have DNS, and it's always DNS. This is basically the phone book of the internet, and it translates friendly names like whatever.com into an IP address. That way computers can understand what it's talking about because they don't understand what friendly names do or what they are. Then we have regions and zones. A Google region is just a collection of zones. Zones have high bandwidth, low latency connections to other zones in the same region. And a zone is just a deployment area in a region. Then we have fiber optics. and this is the method of using light as a way of transmitting data across a glass or plastic strand of fiber. Then we have subsea cables, which are really cool. They're a really crucial element of global telecommunications networks. Basically, the only way that other countries can talk to each other is across these subsea cable network connections. They're literally cables that go across the seabed. Next, we have network edge data centers, also known as points of presence. Google Cloud offers services in over 100 locations in a bunch of metropolitan areas. The crazy part is because of these subsea cables, high-speed fiber optic networks, and the use of points of presence, you're actually only using one hop to traverse the Google backbone network from one place to another, regardless of where you are in the world. And lastly, we have bandwidth. And that's just the maximum amount of data that a wired or wireless connection can transmit over a given amount of time. Lastly, we need to discuss how Google Cloud supports digital transformation with global infrastructure and data centers connected by a fast and reliable network. I hinted at this when I described Google's backbone network, and it's pretty impressive, but let's take a closer look. Hundreds and thousands of miles of fiber optic cable, including more than a dozen subsea cables, are laid out between the data center and internet-facing wide area networks. A machine gets connected from the internet via a public WAN and gets connected to other machines on the network via a private WAN. For example, when you send a packet from your virtual machine running in the cloud in one region to a GCS bucket in another, the packet does not leave the Google network backbone. In addition, network load balancers and Layer 7 reverse proxies are deployed at the network edge, which terminates in TCP SSL connection at a location closest to the user, eliminating the two network round trips needed to establish an HTTPS connection. I highly recommend that you go check out all of the source documentation that I refer to in my GitHub repository, because reading all of this stuff and just synthesizing it on your own is the best way to really learn the material. For example, I listed one of these blogs on the Google Cloud Networking Overview as one of the resources for learning a little bit more about the network. And this is a really good little blog post to read. So that should cover the fundamental cloud concepts, specifically the 5 areas in section 1.2. If you have any questions, let me know. And this was the fundamental cloud concepts of the Cloud Digital Leader Certification Exam.